Okay, I'm going to talk about problems 22 and 24. I'll do 26 later from chapter 15. So in 22, we're told that the probability if somebody goes to Canada is 0.18, the probability to go to Mexico is 0.09, and the probability that they go to both Canada and Mexico is 0.04. So these are given. So the first thing I do is make a two-way table. Canada across the horizon and Mexico vertically. And in the margins, I put 0.09. That's a percentage, that's probability that a randomly selected U.S. resident went to Mexico. And down here is 0.18, which is the probability that a randomly chosen, etc., went to Canada. And then here is the overlap, 0.04. And then the rest of these I fill in by simple subtraction. This is the probability that somebody went to Canada but not to Mexico, probability of C and M complement. So I put in 0.14 because that's 0.18 minus 0.04. So these two cells should add up to the margin here. Similarly, I can go along the margin here, and I know that this is a probability that somebody went to Canada, 0.18. This probability and this probability must add up to 1. So 0.1, 1.00 minus 0.18 is 0.82. So if the probability somebody went to Canada is 0.18, then the Canada that somebody did not go to Canada is 0.82. Similarly, if the probability that somebody went to Mexico is 0.09, then the probability they didn't is 0.91. So now with the margins filled in, I can now figure out this total here, which is the probability somebody went to Mexico but not Canada. So it's simply 0.09 minus 0.04, 0.05. And then finally, since these four cells must add up to 1, and I can subtract 0.05 from 0.82 and get 0.77. Similarly, I could subtract 0.14 from 0.91 and get 0.77 as well. So now I know all these different probabilities, which I'm going to use to answer the questions in just a second. And then I can also make a Venn diagram and fill in all those things as well. And the one thing so anyway, and this 0.77, by the way, is probability that someone did not go to Canada and not Mexico. That's the probability of now, what I don't have here is the probability of Canada or Mexico, which is easy you don't see it in the table. But you would get it from adding up these three numbers right here and leaving out the not Canada and Mexico. So 0.05, 0.09 plus 0.04. So that would be what, 0.22, I guess, or whatever. 9 and 4, 23.23. Anyhow, all right. So the first question is, if somebody, what's probability that someone who has traveled to Mexico has visited Canada too? Now, the way you're going to read this is, given that someone has been to Mexico, what's the probability they went to Canada? So that formula is written, probability that they went to Canada given they've been to Mexico. Well, the probability that they went to Canada given they've been to Mexico is the probability they went to Mexico and Canada divided by the probability of Mexico. This is how you calculate it. Well, we can see from either the table or the Venn diagram that the probability they went to Mexico and Canada is 0.04, and also that's given. The probability of Mexico is 0.09. Okay, so that's 4/9 or 0.4 repeating. Okay, or around 44%, or 0.44. Okay, so the probability that someone went to Canada given they've gone to Mexico is 0.44. Okay, now B, are they disjoint? No, because they have a shared 0.04. Okay, they went to both. Okay, so they're not disjoint. C, are they independent? If the probability of going to Mexico is independent of the probability going to Canada, then the probability of Mexico, the probability you went to Mexico, equals the probability that you went to Mexico given you've gone to Canada. This is the formal definition of independence. If two probabilities are independent, then the probability of a given probability of a given event equals the probability of that event given that the other event has occurred. In other words, the fact that the other event occurs or not makes no difference in the probability of the first event. So the probability that went to Mexico is 0.18. The probability that you went to, alright, so now the probability that you went to Mexico given you've been to Canada is going to be 0.04 over 0.18. Okay, so clearly, which turns out to be 0.22, 0.2 repeating. So 0.2 repeating is not equal to 0.18, so the probability of going to Mexico is not independent of the probability of going to Canada. Probability of going to Canada. Now, for number 24, make a two-way table for species and gender. So we have cats and dogs and males and females. And we're not told very much, but we can fill in the whole table from what we're told. Okay? So local animal shelter reports that it has 24 dogs and 8 cats. Okay? So we're going to fill in the margins here. 24 dogs and 18 cats. Okay, now we know that 8 of the dogs and 6 of the cats are male. So here's the male line right here. So we have 6 cats and 18 dogs that are males. We know we have 42 dogs altogether. So we have 14 that are male, which means we got 42 minus 14, which is 28 females. And let's see. Okay, and then I know I got 18 dogs and 24 dogs and 18 cats. And so I can take 18 from 24 and get 16 female dogs, and 18 minus 6, and that gives me 12 female cats. Okay, so I fill in the 6 and the 8, that's given, and the 18 and the 24, that's given, and from that I can fill in all the rest of these numbers simply by doing subtraction. Okay, now, are they independent? Okay, if species and gender are independent, then the probability of male equals the probability of male given that the species is a dog. Now, you could also do the probability that you're a dog equals the probability of the dog given that you're a cat, given that you're female, or given that you're male, or whatever. There's 4 different ways to do this, but we're just going to do one and see what happens. So the probability that you're male is 14 over 42. Okay? So there's 14 over 42. All right? Now, the probability that the animal is a male, given that they're a dog, is going to be the probability of male and dog divided by the probability of dog. Okay, well, the probability of male and dog is right here, the intersection of male and dog right here. So that's 18 over 42. Okay, and the probability that the species is a dog is 24 out of 42. Okay, which simply transforms to 18 over 24. Does 18 over 24 equal 14 over 42? Yes. 1/3 equals 1/3. So species is independent of gender. And as I said, I will get to 28 later today.